welcome to today's lesson. We want to look at series and sequences. When we talk about sequences, we are referring to a set of numbers which are arranged in a particular order. And this is a typical example of what we are talking about. Okay, so set A and set B, they are all sequences. And each number that we have is referred to as a term under series and sequences. All right. So one key reason why this topic is very important is for us to be able to predict numbers of certain terms. So let's say the 20th term in this particular sequence or the 50th term in this particular sequence. We should be able to predict that particular number. All right. So for these two sequences, they have a pattern. And if you look at it carefully, you realize that the first one, anytime at all we add 3 to the first term, we are going to get the next term. And anytime we add 3 to the next term, we are going to get another term in that order. And that of the B, when we multiply the first term by 2, we are going to get the second term. And when we multiply the second term by 2, we are going to get the third term in that order. So we should be able to predict the subsequent numbers of these two sets. Okay. So just as I said earlier, when we add 3 to this particular set, we should be able to get the subsequent terms. And just to write a few, when we add 3 to 10, we are going to get 13, 16, 19, in that order. And so anytime at all we multiply the second set by 2, you should get a result of 48, 96, 192 in that order. All right. So we have two types of sequences. We have arithmetic progression, which is also known as linear sequence, and we also have geometric progression, which is also known as exponential sequence. All right, so how will you be able to identify one from the other? So it's very simple. What happens is that for an arithmetic progression, which is also known as linear sequence, you have a common difference. Look at it carefully. You realize that between 1 and 4, the difference is 3. Between 4 and 7, the difference is 3. And between 10 and then 7, the difference is also 3. So what you need to do is that our difference, which is D, is equal to the second term, which is 4, minus the first term, or the third term minus the second term. So you realize that all will give you the same results. 3, 3. Sorry, this is 4. So the third term minus the second term, which is 7 minus 4. All right, so that is how you are going to get the common difference. But that procedure wouldn't work for geometric progression, because the difference between 6 and 3 is 3, but the difference between 12 and 6 is 6. So they are not common, they are not the same. So what we are going to do here is that for the geometric progression or the exponential sequence, what happens is that we normally use common ratio. And common ratio, most of the times we use R to represent common ratio. And what we do is that the second term divided by the first term, which must also be equal to the third term divided by the second term, and it must also be equal to the fourth term divided by the third term. And you realize that 6 divided by 3 is 2, 12 divided by 6 is also 2, 24 divided by 12 is also 2. So our common ratio is 2. So anytime at all you find a common ratio and it's not the same, then it means that you cannot use the geometric progression procedure. Also, anytime at all the common differences are not the same, then you cannot apply the arithmetic progression procedure. I hope this helps, and I'll see you in my next video, and we'll be looking at arithmetic progression into details. See you there. Bye.